A-Base is a development platform that gives power to front-end or mobile developers to build full-stack modern business applications. So where traditionally it takes large teams of various professionals such as backend developers, DevOps people, server administrators, and front-end developers to build an app, A-Base allows only front-end developers to build the whole thing, and we also host it. So you don't, after the app is built, it's running on A-Base, and we take care of auto-scaling, backups, all this infrastructure that traditionally you need to build by hand. We take care of that, and your app is just running in A-Base. Most of you probably know that all modern web or mobile apps, they have kind of client-server architecture, right? So you have the client app that runs in your browser. It can be written in React or Angular or Vue.js. It can be mobile native client. It can be written in React Native or Android, iOS. And there are also programmatic clients, some other third-party systems that consume your API programmatically. So because of this, nature, you always so this gap of the internet between those two things is not that easy to deal with, because server can only respond to requests and clients can only send requests. So it's kind of like this one-directional communication. So back in the day when I started developing, there was only one platform in web. It was browser. There was no mobile. So applications tend to be monolithic, meaning if you only serve one platform, why do you even care about the API? All you care is rendering the screens and this kind of like thing that what happens in between. It doesn't really matter. Like framework, like Ruby on Rails or Django, it kind of takes care of this stuff for you, and you don't even know. You kind of build in, you render in screen server side, and then you serve HTML code from the server. So then things changed because the platform expanded. So now there is mobile, there is tablet, there is web, and you need to serve all these different platforms, and they may have very different presentations. So what happened is basically, so that's what I previously explained. It's called monolithic architecture, when you just have kind of single code base that does everything on the server and on the client. Then what's called API first approach emerged, is when now you have a separation between backend developers and front-end developers. Backend developers, they build API that supposed to be consumed by a variety of different clients, so they don't even know what type of view the data will be presented in. They simply kind of give you data, and the front-end developer figures out how to render this data. So this allows companies to write single API and then have web client, mobile client, and programmatic access all connect to this API. So API became important. So as a standard in this era, REST emerged. So REST is it's a specification. It's like a convention that people decided, let's present our API, let's structure our API this way. So we're going to basically break up our API by resources. So resource could be, let's say if you build in a blog platform, resource is an article, user, a comment, things like this are resources, and you access them by URL. So if you want to get an article by ID, you do get request to /articles/ID of the article, and you get the object with all the fields of the article. So that's all cool. That's kind of like makes API more predictable, more easy to understand how it works, but it has some major drawbacks. So imagine if you're building a simple blog platform and you just render in this one page with a blog post. So what do you have on this page? You have the post content, you have author avatar and author name. It comes from a different table. It comes from the user table. Then you have the list of comments. They come from comments table. And then you have, for each comment, you have avatar of the commenter and the name of the commenter. So you have all this like data, essentially graph, that if you look at REST, to get all this data, you need to do get request to get the article by ID. Then you need to get users by ID to get the author, avatar, and name. Then you need to get list of comments as a separate request. And then possibly for each comment, you also need to query a user to get avatar and name of the user. So you need to really like write all this complex boilerplate, orchestrating all this, bunch of these requests to just get this data for one page. So that's kind of annoying. And what really happens in practice is that people don't really follow REST. What they actually do is they ask backend developers, it's like, hey, can you do me a favor? Can you just create like some weird custom call just for me, so it gives me all the data in one thing and in one request, and I don't have to write all this boilerplate. And then developers are like, backend developers like, oh dude, I'm so busy, I have so many tasks, how about you just do all this? So that's what kind of the dynamic. So another problem with REST is what's called overfetching. So overfetching means that, do you notice the second call, users by ID? The reality, my user object can have a bunch of fields. It can have first name, last name, avatar, age, sex, whatever. It's like many fields. All I need here really is just name and avatar, but it will still return me all these fields of user object. There is no way for me to tell it, hey, I only need this one field, give me one field. So 8base is a platform that built using the latest stack and a very unique approach to our APIs that we use GraphQL. GraphQL is an emerging standard originally developed by Facebook and now open sourced that allows that kind of shifts data querying power to front-end developers. So now a front-end developer can issue very complex data queries against the API without asking back-end developers to manually create custom endpoints for them. So that's a very big differentiator, because GraphQL is growing very rapidly. A lot of big companies like Airbnb, Atlassian, Jet.com, and many others embracing GraphQL. And from my personal experience, every front-end developer who touched GraphQL once, they can never go back to REST or how things were done, are being done now. So I think that's a big differentiator, and the fact that our platform is fully serverless. So it auto scales. You can service one request at a time or thousands of requests at a time without you doing anything, provisioning any additional servers or spinning up idle service waiting for requests. It's all fully serverless. So that's, I think those two elements are it's a very big differentiator for our platform. So Facebook, when they basically invented GraphQL, they invented it to address the problem that when they started expanding in emerging markets like India, for example, where internet connection sucks and it's mostly mobile. So they like, how do we reduce the traffic? How do we make it faster for our users? So they came up with this concept of GraphQL where you are able to request using special query language. You're able to request the data that the exact data that you need, and nothing more and nothing less. So like, for example, we're gonna in a second we're gonna build a little blog platform together and see how it works. So first of all, you get all the data in one request. Then you only request what you need, and then GraphQL is also typed. This is actually a big deal. It's essentially with REST it's kind of opaque. So you have this endpoint, you have /author /ID, but you don't really know what parameters this endpoint have. What filtering, what basically what you can send to it additionally to modify the response, and then you also don't know what it returns unless you try it or maybe read the docs. That's the only way to find out what REST API will return to you. GraphQL is fully typed, meaning it's in advance. You can tell exactly what each endpoint receives, what parameters it has, and what it returns in response. So you don't even have to really read the docs. You can just browse through GraphQL Explorer and see the entire API surface. And that gives you, first of all, IDE autocomplete. So you now can autocomplete your queries. I'm going to show in a second how it works. You can catch a bunch of errors at build time versus runtime. So imagine a situation, you use some field for filtering in your query, and then suddenly on the back end they change the name of that field. In REST, there is no way for you to catch it before actually you find a bug in production. But with GraphQL, a special plugin can scan your front-end code and it can highlight, it can tell you, it can basically fail your build, saying that, hey, you're using the wrong field. The field changed on the server, so you can go and fix it. So, cool. Okay, with that, let's skip this for now, and I'm going to just show you the demo of the blogging scenario that I was talking about. So I suggested that you all follow along. So if you don't have account in A-Base, create one. It's free, abase.com. Can you guys raise hands how many people actually logged into A-Base, just so I know? Okay, awesome, good. Almost everyone. So what we're going to do is we're going to replicate same scenario with the blog platform, but show how the same thing can be achieved with GraphQL much easier. So let's create a couple tables. Let's do a table that's called post. It will hold our blog post text. So let's make 1,000. It can probably have a title. Oops. So it can have a title, and I think it's good for now. Then we can create author, which can have name. Again, in real life, it will be a little bit more complex, but all we care is showing how GraphQL works. So author can also have an avatar and its file. And now we need to connect the two. So we drag author on post. So essentially, let's see. So one author can have multiple posts. Yeah, that's true. Multiple authors per post, probably not. So we create it this way. And we also need comments. So we do comment. We'll have text, maybe 500 characters. Comment will also have an author. So multiple comments per author, multiple author per comments doesn't make sense. So keep it this way. Cool. So we have this little data structure here. So how about we populate it with some test data in the data tab? Let's say avatar. I don't even know if I see if I have some images here.
So within your
author
table, you put post, or within your post table you put content?
Let me show you.
Sorry.
So yeah, no problem. You can actually do it both ways because it creates fields on both sides. So what I did is I open post and I drag author into it, but you can do it vice versa. It doesn't matter. As long as your relationships here, as long as your one-to-many, many-to-one is correctly set up. So okay, so let's add maybe a couple authors. Yeah, I'm gonna just use some weird files for avatars. So let's see something. Maybe that's better. Okay. See, a couple is enough. So we have a couple authors. Let's do some post. Some post content. Let's say John wrote this.
No, I can't.
Huh? So,
No, sorry.
So post 2, some blah 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 text here, written by Andrei. Then we can also create a couple comments. Oh, by the way, I forgot important thing. I forgot to connect comments and posts. So we can open the post table and drag comments onto it. Rename it to comments. So allow multiple posts per comment, no. Comment can only be attached to one post, and then allow multiple comments per post, yes. So let's name it post here. So by the way, this relation field name is, so when I created field comments here, in the comment table now, I have a field called post that links to the post that this comment associated with. So basically every relationship is two sides. It's kind of like a mirror. You either go from post to comments, or you can go from comment to post. So that's why we added this field here. All right, cool. So let me, for the posts, for the comments that I created, I'm gonna add them to a post. Second. Yeah, okay. Okay, so this, let's add a couple more. All right, cool. So we kind of populated with some data. So let's go and see how we can query all this data in a single request without worrying about orchestrating all this series of requests. So 8-base automatically, because we created all these tables, 8-base automatically generated CRUD queries and mutations for all these tables. So let's see how we would get data for this single individual blog post page. So we would do post. So first of all, let's grab, let's make this select fields, make ID visible. Grab this ID. So let's say we want to render post 1. So we do query post by ID. So this query returns an individual data object. And let's say we want when the post was created. We want the title, text, author. Okay, so I also need the author of the post. I need the name of the author. I need their avatar, and I need the download URL so I can show the avatar. And I need comments. And maybe, let's say, I don't need to show all the comments. What if it's thousands of comments? So I say first 100. And I probably want to know the total number of comments. And for each comment, I want to know the text of the comment, its author, author's name, avatar, and download URL for the avatar. So this, we actually don't need this stuff. So as you can see, it returns entire data set in a single request. So it's much, much easier on the front end. You don't have to write all this boilerplate that can be buggy. You don't have to ask your backend friends to give you write special query for you. You just do it this way and you get only what you need. You don't waste traffic on some fields you don't show. And it's awesome. It's like, as a front-end developer, everybody I know who touched GraphQL, it's kind of like, it's like a black hole. It just sucks people in. Like once you experienced it, you can never go back. Well, hackathons, first of all, we just love hackathons. I love participating in hackathons myself as a hacker. I think it's a great way to meet other people, to learn new technologies, to try something, accomplish something in a very, very short period of time. But as a sponsor, because our platform is a development platform, it's for developers to accelerate their work, so it fits perfectly at hackathons. We find commonly that people who use our platform at hackathons, they become the winners, because we, by giving them everything a traditional application would need, giving them out of the box, we save hours of work setting up all this infrastructure so they can focus on true innovation, something unique, something cool about the app, like maybe user interface or something like that. And we take care of the back end. That allows people to achieve much more within the same period of time. So the response to 8-base at hackathons has been amazing, and we will continue sponsoring. At our previous hackathon that we sponsored, guys who actually won one of the prizes, they just basically took this starter kit, starter application, just changed the views, and it allowed them to build UI very, very quickly. Hackers should use 8-base to save a bunch of time writing redundant boilerplate and setting server-side resources. In every application, you need to set up the database, set up the API, set up some type of permission and identity around this API. So usually these things take quite a lot of time. It takes maybe several hours to even set up some type of basic API in, let's say, Node.js. With 8base, you just configure your data model, and the API is there out of the box. And it allows you, it includes pagination, filtering, full-text search, complex queries of dependent objects, and it just basically it gives you a leg up in Hackathon because it just saves you tons of time that you can invest in building something to impress judges. Strategic advantage of utilizing GraphQL is basically as the world gets more connected. For traditionally, organizations were trying to protect their data. They were trying to kind of like, okay, we own this data and we're not going to give it to anyone. Now everything shifts towards we have all this data. How do we expose it? How do we become a platform so that other people can build on top of our organization data? And GraphQL is an amazing technology that serves this need because it allows you to expose your business data in a agnostic way, agnostic to how it's used. So you don't have to anticipate all kinds of applications that can be built around your data. Just give the data out there and let people figure it out.